Hello everybody and welcome to your Chem 113 review on significant figures. My name is Jason and I work for the ASU Tutoring Centers. Now Sig Figs. There are four major rules when working with Sig Figs. Okay, the first one is zeros between non-zero digits are significant. Okay. So what this means is, for an example, the number 1005 has 4 sig figs. Okay, because we include the zeros in the middle here in our count of the number of significant figures. So the 1, the 0, and the 5 are all significant, giving us 4 sig figs. Okay, second rule. Zeros at the beginning of a number are never significant. Zeros at the beginning are never significant. As an example, if we look at the number 0.0026, this one only has 2 sig figs. These zeros up front, these right there after the decimal place and these before the decimal place, do not count in our measure of sig figs. Okay, so any zeros before a number starts are not significant. So this one only has the 2 and the 6. Okay, third rule. Zeros that fall at the end of a number and after a decimal place are always significant. Zeros after a number, after a non-zero number, and after a decimal point are significant. So as an example, if I look at the number 0.0200, this one has 3 sig figs. So the zeros that come beforehand don't count, but the zeros that come afterwards do count. So this one has 3 sig figs, the number 2, and then those 2 zeros after it all count towards the sig figs. And then the fourth rule of sig figs, when a number ends in a 0 but contains no decimal point, we have to be a little careful here. The zeros might count or they might not. Zeros after a non-zero number, but before a decimal place, may or may not be significant. It's kind of lame. That's a sometimes rule. So as an example, the number 130, this one could have 2 sig figs, or it could have 3 sig figs. It's kind of hard to tell. Do we include this 0 or do we not? So to avoid that ambiguity, we always like to use scientific notation. Okay? By using scientific notation, we avoid that ambiguity entirely. So for instance, the 130 here, in scientific notation, we could write it as 1.3 times 10 to the second, at which point we would say this has 2 sig figs. Or we could write it as 1.30 times 10 to the second, at which point it would have 3 sig figs. Heck, we could even write it as 1.3000 times 10 to the second, at which point it would have 5 sig figs. So using scientific notation helps us avoid these sort of ambiguous cases where they may or may not be significant. Okay, so hopefully the stuff you'll be working with will be in scientific notation, so you don't have to worry about whether to include the 0 or not. Cool. So these are the rules, and we'll be using them here. So significant figures help us when we're adding, multiplying, doing any sort of arithmetic with our numbers to decide how many digits are significant. And that's an important thing in science. It sort of goes into how accurate your measure is, right? If I have 12 significant figures and I multiply it by something that has like 2 significant figures, well, I'm only going to want to record 2 sig figs in my final answer, right? Because the accuracy of my final answer depends on which of my two measurements is least accurate. So which one has the least number of sig figs, right? If I multiply something that's super accurate, like down to 87 decimal places, by something that doesn't have any decimal places, that has like one significant number, I have to be aware that that's going to skew how accurate my final answer is. So we'll go over those rules as we come across them. But that's why sig figs are important. So here we are trying to find the density of a gas. So let's remember what density is. Density equals mass over volume. So if we want to find the density of this gas, we need its mass and we need its volume. So we're told that the volume of the container is 1.05 times 10 cubed centimeters cubed. Okay, so we already have the volume. Check. So the last thing we need is the mass. So when we have the gas in the container, it's weighed and found to be this much. When we don't have the gas in the container is weighed to be that much. So if we want to find the mass of the gas, we would have to subtract those two weights, right? If we take the mass of the gas plus container minus the mass of container, all we'll be left with is the mass of the gas. So to do this, we take 837.6 minus 836.2, and then we see what that number ends up being. We get 1.4. Now, how do we work with the sig figs here? Well, when adding or subtracting, it's not really based on sig figs necessarily, it's based on decimal places. So we keep the least amount of decimal places when adding or subtracting. So in this case, we had one decimal place. In this case, we also had one decimal place. So the number of decimal places we will keep is one decimal place, which we do have in this answer, right? 1.4, we only have one decimal place, that 0.4. Okay, so we already have the number of significant figures. Fantastic. So now if we want to find the density, we now have the mass, right? It's 1.4 grams. And we have the volume, which is up here. So the density of our gas would be 1.4 grams divided by 1.05 times 10 cubic centimeters. How do we find that value? Well, I mean, we can just do the math, right? Let's do the division. 1.4 divided by 1.05 gives me 1.3333, on and on and on, times 10 to the negative 3 grams per cubic centimeters. But how many decimal places should I go to, right? Those threes keep going on and on and on and on. How many should I go to? Well, when you're multiplying or subtracting, multiplying or dividing, you keep the least number of sig figs. So you look at the two things you're multiplying or dividing, you see which one has the least amount of sig figs, and that's how many sig figs your final answer should have. So if we look here, 1.4, that has 2 sig figs. Just in the fact that there's 2 things listed, both of them non-zero. Don't have to worry about any of those weird rules with zeros. If you look at the bottom portion, 1.05, so this 0 is included, right? Because the 0 is between 2 non-zero numbers. So we include that in our sig fig calculation. So basing it off of this 1.05, we have 3 sig figs. So we have 2 sig figs divided by 3 sig figs. Our final answer, we have to keep the least number. So our final answer should only have 2 sig figs. So rounding as I need, I'm essentially going to be dropping all of these extra terms. My final answer will be 1.3 times 10 to the negative 3 grams per cubic centimeter. We only have 2 sig figs. Okay, so those are the 4 major rules for counting the number of sig figs, and then the rules when it comes to adding, subtracting, multiplying, and dividing for how many sig figs our final answer should have. Cool. All right. So as I mentioned at the beginning, I work for the ASU tutoring centers. So if you want more information about the free services we offer on all 4 major ASU campuses and online, please check out tutoring.asu.edu. If you want more videos like this one that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for the exams in your course, please check out this link below. Thank you all for watching, and I hope you have an awesome day.